Okay, so imagine this. You're running digital operations for a huge global hotel chain. Every single day, thousands of customer reviews are just pouring in from everywhere. And you used to just, collect them, maybe run some sentiment analysis and pop it in a report. Pretty passive stuff. But now the goal has changed. The mandate is you have to reply, not just to some, but to every single review. And you need to automate these replies so they sound human. At a massive scale, you're basically turning passive data into an active conversation. That exact shift from just analyzing to actively engaging with thousands of customers a day, that's the strategic challenge we're really digging into in this deep dive. We're talking about Snowflake Cortex, which lets you generate advanced AI text without ever having to leave your data cloud.
Exactly. The core idea here, the real solution, is that the AI capability is brought directly to your data. It just completely eliminates the need for managing all these complex external APIs.
Right, or spinning up separate infrastructure for the models.
None of that. And this is the critical part.
Yeah.
You're not moving sensitive customer data anywhere. It stays put. So when you're at this fork in the road deciding how to build these automated replies, you've got two really powerful native options in front of you.
And that's what we're framing as path 1 and path 2. Path 1 is the Python workflow that's all about flexibility. And path 2 is the SQL workflow, which is just built for pure, unadulterated scale. Our mission here is to figure out not just how they work, but more importantly, which path you should strategically choose. For you, our learner, this is like knowing when to build a precise prototype versus when to fire up the mass production factory.
It really is. It's all about understanding the different kinds of workloads. I mean, is your goal to do rapid iterative development? Maybe you want to try out 3 different models, chain a few steps together. That's one path. Or is your main business goal just to get accurate, predictable replies out to 50,000 reviews by 8 a.m. tomorrow? That demands a totally different approach.
Okay.
And the platform is built to handle both.
So before we get into the real technical nitty-gritty, let's just touch on the operational benefits of doing it this way, of having it all integrated. Because moving from passive analysis to active engagement is a huge strategic shift, but it usually comes with a ton of IT friction.
It does. And that friction, it usually comes from 2 main things, complexity and security.
Yeah.
Historically, if you wanted to use a large language model to generate a response, you had to pull that review data out of your data warehouse, send it over the internet to an external API like OpenAI or someone else, wait for the response, and then pipe the result back into your warehouse.
And that data movement is always the pain point, isn't it? It adds latency, it adds cost.
And it exponentially increases your security surface area. Suddenly you have to manage all that. Precisely.
So the beauty of something like Cortex, which runs entirely inside the Snowflake data cloud, is that your hotel chain's secure proprietary data. It never leaves your account's boundary. It stays secure, it follows all the governance rules you already have in place, and you're not juggling API keys and external access policies for sensitive personal information. It just dramatically simplifies operationalizing AI so your teams can focus on the quality of the prompt, not the quality of the infrastructure.
Okay, that makes perfect sense. That foundational security and operational simplicity is key. So with that in mind, let's unpack path 1, the Python workflow. This one leverages the complete function. When should a learner immediately think, Python, this is my tool?
Python is your go-to when flexibility is everything. If your focus is on interactive development, rapid prototyping, or I think the most common use case here is when you're chaining together complex, multi-step AI logic. You're probably working in a Python cell inside a Snowflake notebook, and that's where that flexibility really, really shines. I can see that. For chaining things together, like say I don't just want to reply to the review. Maybe first I want to use one AI call to extract the 3 main complaints, broken AC, slow check-in. And then I want to use a second AI call to craft the reply based only on those extracted points.
Exactly that. That kind of sequential logic where the output of one model becomes the input for the next. That requires the kind of programmatic control that Python gives you. You're not just running a function. You're orchestrating a whole workflow.
Okay, so if I'm building out that complex chain, my workflow starts in the data warehouse. Walk us through the setup and that data flow. Because this is where structured data meets unstructured text, and it can feel a little clunky if you don't understand the why.
It's true. The first step, and this part is unique to Python, is managing that data flow. You start by importing the Snowflake.Cortex module. That's step 1. Then, because your Python environment needs to talk to the structured data in your table, let's call the column review text-t, you run a SQL query, but you run it through your Python session.
And you pull that result into a data frame, right? Which is kind of the standard tool for data work in Python. But why can't the complete function just read the table directly? Why this extra step of turning the text into a simple string variable?
That's the critical glue code step you just identified. Structured data tables, columns, and the world of unstructured text processing for AI prompts. They just speak different languages. The AI model, it needs a clean, simple string, just the raw text of the review to plug into the prompt. The data frame step is that essential bridge. It lets you select and clean that specific piece of data before you hand it off to the language model. You're isolating the text as a pure variable.
I see. Okay. So the flexibility comes with a bit of pre-processing, but that gives you the control you need to do that complex chaining. So once we have that simple string variable, we call it the complete function, what are the absolute non-negotiable parts of that function call?
Two things are non-negotiable. First, the model specification. You have to tell it which large language model to use, like Llama 2.7b chat. And second, the prompt itself. Since we're in Python, this prompt is usually dynamic. You'll use what's called an f-string to inject your review text variable right into the instructions. So your prompt might be something like, as the hotel manager, write a courteous and brief reply to the following customer review.
So the prompt is doing double duty. It's giving the instructions and the content to work with. But this is where we go from just making it work to really controlling it. The generation parameters, that options dictionary, that's what separates a real system from a quick demo. Let's talk about temperature.
Temperature is, well, it's the creativity dial. And it's arguably the most important strategic setting you have. Think of it like this. If you set the temperature to 0, the model becomes hyper-predictable. It'll always pick the most statistically likely next word. It's like using a GPS. You get the shortest, most efficient route every single time.
And for automated customer service replies, where you need that consistency in brand voice, a low temperature like, say, zero point 0.3 is probably the business requirement, isn't it?
Absolutely. You want predictable, focused, on-brand responses. A high temperature, something closer to 1.0, that's like taking a scenic road trip with a bunch of unexpected turns. The responses get creative, they get diverse, and they could get wildly off topic. You'd use a high temperature for brainstorming marketing slogans, not for automated service replies.
And the other big control is max tokens. This sounds like a hard limit on the length, which I'm guessing has some major cost implications.
It really does. A token is basically a word or sometimes part of a word. If you don't limit max tokens, the model might just keep writing and writing to complete your prompt until it hits some massive internal limit. And you're paying for every single token it generates. So setting a hard cap, maybe 150 tokens, is essential for keeping replies concise, relevant, and for managing your budget on these massive operations. Path 1 gives you that fine-grained programmatic control.
Okay, that's path 1, flexibility, interactive development, and that necessary data bridging with Python. Now let's switch gears completely. Path 2, the SQL workflow powered by the AI complete function.
Right.
If Python is the custom high-end workbench, what's SQL?
SQL is the industrial powerhouse, plain and simple. If your priority is generating text across tens of thousands or even millions of rows high volume, brute force batch processing, SQL is inherently built for that. It just bypasses all those intermediate steps we just talked about.
And the big appeal here is just how easy it is to get started, the accessibility. We don't have to import any packages or anything.
That's the first huge advantage. AI Complete is a native function in Snowflake SQL. It's available out of the box, instantly. In any SQL worksheet, notebook, or any client you're using, there is zero environmental setup. For data engineers who live in SQL all day, this is a massive game changer.
And that simplicity, I assume, translates directly to how it scales. How does the declarative nature of SQL handle massive volumes so differently than Python?
Well, in Python, even in a powerful notebook, you're often thinking about data row by row, or maybe in small chunks, and you have to manage that process. In SQL, you're just asking the data cloud to apply the AI Complete function to an entire column of data in one single declarative query. The platform itself handles all the parallelization and the scaling for you effortlessly.
So instead of me writing some complex orchestration script, I can just write one line of SQL, like select review text, A complete, from reviews, and the platform just figures out how to run that for 50,000 rows at once.
Precisely. You are integrating AI generation directly into your existing data transformations, your ETL or ELT pipelines. This completely removes the burden of managing external compute or worker pools that you might need to scale a really big Python job outside the data platform.
Let's break down the function structure then. If we're not using Python's f-strings, how does the SQL function handle the prompt?
The structure is a little different. It's tailored for SQL. You still specify the model in the prompt, of course, but the prompt uses a generic zero-indexed placeholder, it looks like. So you write the instruction like, write a courteous reply to this review.
And then the data source, the column with the actual review text, is passed in separately as the second argument.
Correct. You define the instruction template first, and then you tell it which column's data to plug into that placeholder for each row. It's just a cleaner way to do it for batch operations since you're referencing a whole column, not one specific string variable. And critically, you still have the exact same fine-tuning control. You still pass in the temperature and max tokens in the options argument to make sure those replies are predictable and cost-effective, just like you would in Python.
Okay, this brings us to the showdown. We've defined the tools, but for you, the learner, the real insight is that strategic choice. The functions are similar, the controls are identical, but the architectures are worlds apart. What criteria really dictates the decision?
Yeah, we have to go beyond just listing features and think about the deployment and the maintenance context of what you're building.
Okay, let's start with the use case. We've kind of established Python is for that interactive development and prototyping. What about SQL?
SQL is for production batch workloads, full stop. If you're building a system that runs every single night to clear out the backlog of reviews and generate responses for deployment, SQL is the champion. It simplifies what could be a 100-step pipeline down to one clean, elegant query.
And the environment difference, that matters a lot for team structure too. With Python, your team needs to be comfortable in notebooks, managing data frames, maybe even integrating other Python libraries for data cleaning or something.
Whereas SQL is immediately accessible to your entire team of data analysts and engineers, the people who already manage your data transformations. The deployment mechanism is just a scheduled SQL task, which is so much easier to monitor and maintain. You're using the language of data for a data task.
So the core distinction really boils down to agility versus integration. If I need the highest degree of complexity and I need to pivot fast during development, I choose Python. But if I need maximum efficiency and just seamless integration into my existing operational pipelines, I'm choosing SQL.
Absolutely. And think about the maintenance overhead. A complex Python system means you're managing dependencies, you're managing environments. That can get brittle. A declarative SQL statement that just calls a native function, that's far more resilient and requires way less specialized maintenance in the long run. The power is in the choice because the platform has already removed the infrastructure problem. So the only choice left is purely architectural, driven by your team's workflow and your scale needs.
This dive into the AI architecture has been, well, incredibly insightful. We started with a real-world, high-volume, challenge-automating customer replies for a global hotel chain. And we've seen how a unified platform like Snowflake Cortex gives you two perfectly optimized tools for the job. Python, the flexible developer's workbench for prototyping and complex chains. And SQL, the scalable industrial engine for massive batch processing. By using these native functions, businesses are fundamentally changing their relationship with their data. You're transitioning from being a passive observer to an active participant, someone who can create personalized, intelligent interactions at volumes that were, frankly, impossible just a few years ago.
And this capability really comes down to the control you have over the output, which we kept coming back to with that temperature setting. We focused on highly predictable, low-temperature AI generation for those customer service replies. But you should consider the full scope of AI application across your organization. And this raises, I think, a really important question for you, the learner. If you applied low-temperature AI to ensure brand consistency in one area, where else could you strategically apply high-temperature AI generation? Where creativity and diversity are actually encouraged, like generating content for a new marketing campaign or for internal problem solving. And crucially, how would your metrics for success be completely different between those two use cases? That strategic balancing act, that's a next layer of complexity for you to go and explore.